Ginger, and welcome everybody. This is the first ever, I think, GTAP virtual seminar. So we're very happy to be able to organize this. Let me start by sharing my screen. It should be. I hope everybody can see my screen. Otherwise, I'll hear. So welcome. This is a virtual seminar. It's a first of its kind. So we're kind of trying to figure out what we're doing as we go along. And in the next hour or so, we want to present the recent work that we've been doing with a consortium on baselines for dynamic computable general equilibrium models. And this is part one of this series. And then next week, we'll have a part two, and I'll explain that in a bit more detail in a moment. So the outline of the meeting today is that we start off with a short introduction of the topic, and then that was originally planned that Dominic van der Menspartner would do that, but he had to pull out at the last moment, unfortunately, so I've taken over as moderator. I will then smoothly move on to my own presentation, which introduces this topic of shaping baseline scenarios of economic activity with CGE models. And then we move on to two speakers that will dive deeper into specific items. First, Jean Fourré on the macroeconomic drivers of baseline scenarios in dynamic CGE models, and then Mun Ho on modeling consumption and constructing long-term baselines in final demand. All the speakers should limit themselves to 10 minutes so that we have half an hour of discussion at the end before we close the meeting. There's no chance for other people to there's no chance for other people to actually get the speaker function. So for all the participants, I'd like to ask you to pose your questions through the chat function, and feel free to already start doing that while the presentations are ongoing. We don't need to wait for the discussions to collect some of the chats, and then we'll just insert those questions that are rising up in the chat. We'll insert them into the discussion, and then we'll ask the panelists to comment on those. So I hope that's all clear. And then I'd like to immediately go on. We don't need to spend more time, I think. Immediately go on to my own presentation, which is about shaping baseline scenarios of economic activity with CGE models. This is joint work with Dominic van der Menspartner at GTAP and Bert Sevijn with the EU JRC. So we have an informal calibrating CGE baselines project. It's kind of a consortium of modeling teams that came together and decided that actually we feel that on balance, CGE models can do a better job on making baseline projections for the coming decades. And this comes up with kind of an analogy of what happened when GTAP was created. Because when GTAP was created out of this need for having more economy-wide data that can be shared between global CGE models. In the old times, everybody would build their own social accounting matrix, and they would all build their own data sets. And of course, that's very inefficient. And it was clear that there's a strong incentive to work together and to share more information. And therefore, the GTAP was born. Now, we don't want to be necessarily as ambitious as GTAP in making baseline projections, but we feel that it's a very nice complement to the current set of tools that GTAP provides to start working together better on baseline projections. So we started this informal project with an initial GTAP OSD workshop in January 2018, where we invited a number of modeling teams to basically inform everybody else about what they're doing in terms of baseline projections. And that workshop then led to follow-up activities where we officially invited modeling teams to work together and create a special issue. So that special issue has been issued in the Journal of Global Economic Analysis. And that was in June this year. And there that basically summarizes all the work that we've been doing in this consortium. And the consortium consists of 26 participating modeling teams And I think there are also a number of individuals that were not necessarily affiliated with a specific modeling team that are still participating in some of the analyses. This gives us a very good broad view of what the major modeling teams are actually doing on baseline projections in CGE models, with a focus on global CGE models. This is really dedicated to global CGE modeling. Now, having said that, we do feel that there's a bunch of stuff to be learned also for people that do national CGE modeling and that want to do dynamic projections for an individual country. Of course, you'll have different data, you'll have different objectives if you do national modeling than when you do global modeling. But even though the consortium focused on global modeling, this will definitely have also benefits for regional and national. Now, this is an informal consortium, as I said, so that means the project will continue as long as people volunteer to work on it. It is just purely driven by people's willingness to learn from each other, people's willingness to put in time, to write papers, to do model comparisons, etc. So we managed to do that quite well in the first round when we made this special issue. But as we go along and as we continue in the future, we have to still have people that volunteer to actually do some active work. And I'll get back to that at the end of my talk. We might also try to get the annual GTAP meeting as the kind of conveyor to keep the discussion going. So we're looking into trying to find something like a side event, a lunchtime side event or so, for people that can just walk in and then see whether they want to be part of this or ask more information, etc., and develop new ideas. So what are the key elements in calibrating CGE baselines? Well, first and foremost, of course, you need base year data. Any CGE model needs base year data, and most of us, I guess, are using the GTAP model database, but of course there's other databases out there as well. But what you need is a social accounting match. You need an input-output table or something like that that describes how the different sectors in your economy are linked, how demand is linked to supply, etc., and international trade. Now, many models link that to additional indicators, for example, on nutrition indicators or greenhouse gas emission indicators or other types of physical indicators that you can link to the economic flows that you have in your social accounting markets. And secondly, once you have your base year data, you can look at the trends in the exogenous drivers. So basically the inputs into your modeling that creates this baseline in your CGE model. First is population dynamics. And that is not only population in a sense of that you need to have an outline for population in total, but you also need to think about demographics, like the age pyramid of the population. The differentiation between men and women can be very relevant. You can also look at urban versus rural populations, for example, and all these can feed into kind of what you would say as what would drive your labor supply, for example. But also it would drive your effects on welfare by looking at per capita outcomes. A second set of exogenous drivers that can be looked at are the technology side. So basically this includes factor productivity, labor productivity, but also total factor productivity, cost structures for firms, and consumer preferences on the demand side. So normally most models have some sort of demand evolution, but you could also think of actually changing the preferences that consumers have over time. You can also imagine that there might be trends in the trade data. So we'll learn about all these drivers. We'll learn them in the following talks. A third set of elements that you need is expectations. So there are basically three types of CGE, dynamic CGE models. You have the ones that are recursive dynamic, you have the ones that have kind of perfect foresight, and then you have some models that are in between and that have adaptive expectations or something like that. But you need to make some assumptions in your modeling on what savings will do, how savings are decided, how savings are aligned with investments, and how much foresight your consumers and producers have in your model. And finally, you need to make assumptions when you calibrate a dynamic CGE model on policies. Now, this includes current policies. So, for example, if you do a study on climate change, you cannot simply assume that there is no climate change policy currently going on, because, for example, the EU already has its EU ETS, and other countries also have policies that affect carbon emissions. So you need to have some idea of what current policies look like. And you also need to figure out how these evolve over time. Do they still have an incentive to change some model parameters over time? Or can you assume that these effects fade off over time, etc.? And finally, you also need to think about policy developments outside the domain that you're studying. If you're doing a climate change study, but you have no idea about energy efficiency, then of course you're making the wrong projections. So how do we set up this special issue that we have? And in that sense, what are the major elements in a CGE projection? So first, we look at macroeconomic trends, and then from that we derive macroeconomic projections that then feed into CGE projections. This will come back in the next topic, in the next presentation. Second of all, you need to look at the demand trends. So what happens to consumers, government, investment sector, and that will also be presented later. Then the third element that you need is looking at producers and how they evolve over time. So basically the supply trends. Next, you could look at special sector trends. There's a lot of models out there that have dedicated modules for agriculture or dedicated modules for energy, and that have outside information that's better than what the more broad demand and supply trends can deliver. So they have specific sectoral trends that they incorporate into the CGE model. Then you might couple your CGE model to physical trends. This could be about nutrition, to have a look at whether your demand for food actually makes sense from a nutritional perspective, but it could also be energy and greenhouse gas emissions. And then finally, any CGE model is not an autarky, so you always need to look at trade flows between the domestic economy and the other economies. Now, in a global model, of course, that's a whole set of economies that you're representing at the same time. So these trade flows are basically just linking between the different regions that you have in your model. But for a national model, you would normally assume a small open economy that has trading relationships with the rest of the world. But it's still, you have to identify how these trade flows evolve over time. So for today, we have two excellent speakers lined up. Jean Fauré will talk about the macroeconomic trends and how that feeds into the CGE projections, and also how these macroeconomic trends and the assumptions you make there, how these affect CGE projections and baselines. And then we have Man Ho, who will talk about the demand trends, so the consumer side, and how that affects CGE projections and what the different modeling teams do. And next week, we have the second set of speakers, Jean Chateau on supply trends, Matthias Weitzel on specific sectoral trends, Sergei Palchev will talk about the physical trends and energy and emissions, and Eddie Beckers finally will talk about trade flows. So it's really a set of two seminars that together give you a good overview of what happens in what we have done in the special issue. So what's the next step for our informal consortium? We have the idea that looking at what people are doing, we can learn a lot from that, but actually what we would really learn a lot from might be a numerical comparison exercise. There are other consortia that have done that. For example, the integrated assessment modeling community does that regularly, where they look at numerical comparison. The Energy Modeling Forum does energy comparisons. AgMIP does specific comparison exercises on agricultural modeling, including a bunch of CGE models, both in the Energy Modeling Forum and in the AgMIP agricultural model comparison exercise. So we're thinking that maybe it would be good and it would be time to do something similar to that for what the what the big CGE models, the global CGE models do out there in terms of comparison across models on baselines. Second thing we want to do is a repository of baselines and a wiki of underlying models. Basically, trying to get that people have better access to what the best models out there actually do in terms of baseline projections, and why, what the underlying assumptions are in the models that they use. So some form of a repository where people can just go to and see what other people are doing. And the third item is we want to do some outreach to make sure that CGE modelers, when they start doing their CGE modeling, they don't feel lost and alone in a sea of where they don't know what to do, but that they're actually aware of this exercise and that they can build on this exercise to then make their life a little bit easier. So we've set up a website. For now, it's a very first step. So there's basically just one static page. It's at the GTAP website. It's called CGE Baselines. And you can follow there whatever is going on. But if you want to be actively involved in this, and I want to stress that we really want to hear from you on what you want out of this, what you're willing to contribute to this, and that one doesn't necessarily need the other. You can also just say, it would be great if you could do this, but I cannot participate myself. I'd just love to hear from you, what you want to do, what you have to contribute, what you want to get out of this. So we have set up an email, cgebaselines@purdue.edu, for people to get in contact with us so that we can set up the next steps of our project. So with that, I thank you for your attention, and I invite Jean to share his screen. I might have to give up mine. Let me see whether I can do that. No, I'm not managing, Jean, sorry.
Actually, I don't have a presentation, so
okay, so
it's okay.
Please start talking. I'll start my screen up.
So thank you very much, Rob, for this introduction, and thank you, GTAP, and OECD for organizing all this informal working group. So as Rob presented, I will talk about one of the paper in the special issue, which is the one on macroeconomic driver. So to be more specific, what we dealt with is factor accumulation and GDP projections, GDP and productivity projections on a quite aggregate level, because we try to remain generic, and because a lot of, actually it concerns most sectors, and a lot of details and more in-depth detail was provided in the different papers that are coming afterwards. So we stayed at generic level for all CGE models baselines, and we focus somehow on the different trade-offs that the modelers face when building their baselines. So we'll start with the different factors, then go back to GDP to go through the outline of the paper, and then focus a bit on what we recommended. I forgot to mention that this paper was a joint paper by 10 co-authors, so feel free to consult it online. So regarding factors, there are a lot of assumptions that are made by the different models, and not necessarily always the same. So there's quite a diversity here. So the first factor, which is the same first one as Rob mentioned, is population dynamics and demographics. What we saw in the different models is that regarding demographics themselves, the practices were quite uniform. Everybody relies somehow on exogenous population projections by IASA or the United Nations. And the difference comes in how it is implemented in the model. So do the model consider labor force as working age population, or labor force as a proper labor force, as economically active population? And the second difference is regarding the skill level, because there are some models that have a difference in the skill level of the population, mostly between skilled and unskilled. And here there is no real consensus, and this is because the projection data that exists are focusing mostly on the education level, while the CGE data and GTAP data is based on occupations and not on education. So there is here a kind of inconsistency which makes the modeler's life a bit difficult if he wants to take into account skills. So basically, it's a trade-off between data availability and the plausibility of the baseline regarding the population, but only when entering into the detail. Regarding savings and investment, so this is the capital formation, which is the second main factor. What we saw in the different models is that there is a kind of consensus considering that savings should be considered exogenous from a certain projection sources or under some assumptions, whereas the investment adjusts to match both the savings behavior and other constraints that I will go back to afterwards. And here, regarding savings, there are some different practices, but some of them consider savings as constant over time as a share of GDP or of world GDP. And it is somehow at odds with what is observed in the data. So there is something that can be done, whether exogenously from an exogenous projection that is existing, or endogenously within the model with propensity to save behavior. The second constraint to build the capital formation is on the current account, so the difference between capital, between investment and savings at the level of the country. And here, the trade-off is really between simplicity, because there are some simple assumptions that can be made, and the plausibility, because these simple assumptions are sometimes at odds with the macroeconomic literature. So just a precision, so the current account is strictly equal to the trade balance, and that's many of the reason why there is no consensus here, because whether we consider it from the macroeconomic perspective or trade perspective, the determinants are not the same in the literature, and the assumptions you can make are different. So what we identified is that certain practices were quite at odds with what has been observed in the past data and in the macroeconomic literature. The first one is to consider simply a fixed current account that is not evolving over time. And the second one is to assume a simple convergence to zero of the current account deficit or surplus. And so basically that's what we identified. Regarding the other factors, these are more or less not present in every model. So the other factors are, of course, natural resources and land. So regarding land, it is once again a trade-off between simplicity and plausibility, because there are some very simple assumptions like a constant supply of land or an exogenous, let's say, trend, but that are not necessarily well fitted. Whereas there are some other approaches like implicit or explicit land supply curves, or exogenous but more refined supply factor supply that seems accessible for most modeling team in simple implementations, but not a lot used in the different models we reviewed. And finally, regarding natural resources, there are really two kinds of natural resources in the model we reviewed. The first one is fossil fuel resources, because these have been studied far more than others. And regarding this, the trade-off that we identified is more between complexity and consistency, because most models calibrate these resources So using supply curves or price target and an endogenous determination, calibration of fossil fuel reserves. But this implies a risk of inconsistency sometimes between the projection used to calibrate and the actual content of the model. On the other hand, you have the possibility to have a real resource depletion model to have an endogenous, to handle endogenously the fossil fuel resources within the model. It's better because it's completely consistent, but on the other hand, it's more complex in terms of data and modeling requirements. And finally, we also considered quickly, unfortunately, the other resources, and we considered it very quickly because actually not a lot of teams have done anything for these resources. I'm speaking about fisheries or other minerals, for which actually the assumptions are very simple. And maybe that's something that has to be studied further. So these are the different factors. And the second theme that we considered was GDP itself. So whether it is GDP projections or calibration of the total factor productivity based on existing GDP projections, because these are the two different approaches for which there is a trade-off between the control you can have over your baseline. If you have if you calibrate directly productivity using assumptions that you can let's say refine on a sector basis, etc., you have more control on the trajectory and on its plausibility. Whereas if you consider simply a GDP trajectory based on macroeconomic projections, it's easier because you can rely on the macroeconomic growth literature, but you also lose a bit of control over what happens in your baseline. And regarding these GDP projections, actually, the practices are quite homogeneous, and there is no real problems that we identify with it. Only two issues that are dealt with in the paper. The first one is data projections, data sources, sorry. So there exists a wide range of available projections that in the medium term can diverge a bit, but in the long run, actually they are quite alike. Alike in terms of global trajectory, but also in terms of regional allocation of growth. So the second issue is the unit that is used in the models to implement the TFP calibration procedure, the unit used for GDP projections. And there is a focus on the fact that purchasing power parities are far more consistent with the theory than market exchange rates while doing so. So as a conclusion, and I think I will be somehow on time, the main recommendation that we have is first, really to take care to have a link with the related fields in the literature, not necessarily within the CGE literature, but more on the macroeconomics literature. And this helps having really a theoretically consistent baseline. And the second recommendation that we make is a recommendation about consistency, because most of the baselines are based on different sources, different data sources that can be one at odds with the other. So it's not always possible to take everything from the same source, because it might require to build a specific model to fit, a specific macroeconomic model to fit your CGE model. But if it's not possible to take everything from the same source, at least some checks about the consistency between the underlying assumptions that are behind the projections that are used can be very useful. And finally, we also set up first research agenda on the topic with two different directions. So the first one is luckily what will be the case with this informal meeting is really go deeper in the comparison and in the documentation of the different practices. So this is something that is already ongoing. With only us, we identify the complete lack of information on non-fossil fuel natural resources. The second direction that we thought was interesting is in terms of research agenda, is to focus a bit more on labor issues. First, because there is a lack of data available on economically active population projections. Actually, the ILO is providing one, but not in the long term. And otherwise, there is no consensus on how to do these projections. And the second is also the questions of skills. As I mentioned before, there is an inconsistency somehow between what is considered as a skill in the macroeconomic projections literature and in the CGE modeling literature. Whether we consider education or occupation as a definition for skill, as well as in the measurement of this skill intensity within the sectors. And finally, what we identified is that there is also a complete lack of consensus and on the question of unemployment that might become more and more important, and maybe having more data on skills, more data on economically active population would help in considering unemployment, but maybe it's the second step that we consider. So thank you very much.
Thanks a lot, Jean. I'd like to remind people to use the chat box for if they have questions. I see some people raising hands. I think our host explained to me that we cannot have people raising hands and then giving them the floor. So if you have questions, please just use the chat box. And I want to urge you all to ask many questions and to fill that chat box up while we have the presentation, so that we can have a good start of the discussion immediately after. So with that, Man, the floor is yours.
Thank you. Let me share my screen. Can you tell me that if you can see my slide?
Yes, I can.
Okay, thank you. Thank you, Rob, and the organizers for this online seminar. So this paper is done by many people. I hope they are here to help answer questions. This is I'm sorry to say, a very long paper. It was even longer in the beginning, but we have separated it out into a supplementary appendix. In part, this is because we not only talk about consumption, but also investment and government. I think a good baseline should take into account the historical behavior and the estimated elasticities. And so this chart illustrates some of this point. This is a consumption function that we estimated for China. This is the top tier with only 4 baskets. So the blue line is the food share, rapid fall in the food share, and then the flattening out. This flattening out is in part because we included restaurant in our definition. And the orange line is the housing share. So there's a lot of change in the housing prices. So this is to emphasize that we really need all the elements in a model: the price effect, the income effect, the demographic effects. We list in our paper a set of empirical estimates, papers that supply some of this demand elasticities. So the top table is a table of income elasticities, and the bottom one for price elasticities. I put them up here just to emphasize that you can see that the elasticities are very different for the different goods, very different for different countries, and even for the same country, different across time. This slide is to remind me to tell you that we have a separate section in the paper for food and energy modeling because of the big interest in these aspects. Again, this is to show that within the food group, the elasticities are very different, and the energy is quite complicated from the work in the empirical literature. Gasoline, for example, is a luxury good for poor countries, but is quite inelastic for the richer countries. So in the next part of the paper, we talk about the actual functional forms that are used. So here is a result of the survey that we sent out of the different functional forms for consumption. The CES is the most popular and the LES, but CDE also have 6 out of the 50. There is a very long table that describes the main features of each model, how they deal with the consumption parameter adjustments, and also how they model the energy part of the model. Thanks to everyone who responded. In the supplementary appendix, we summarize for convenient reference the various functional forms, the common functional forms. Here I give a few: the CES, LES, CDE, and IDEX. We write down explicitly the income and price elasticity formula, so you can compare the complexities of the different formulas. And we compute the number of parameters to give you an idea about how many parameters needed to be calibrated, somehow projected. And we also talk about flexible forms. By flexible, I mean those that have cross-price elasticities. We talk about the advantages and disadvantages of these different functions. So, for example, the flexible function gives cross-price elasticity, but has a strong implication on the softness. Next, then, is the heart of the project, which is how to think about using these models to project over a very long horizon. I think it's convenient to divide these different methods into 2 groups. One we call the complete demand system approach, by which we mean that one consumption function with unchanging elasticities is used for the whole horizon, where the only things that are allowed to change within the function are the exogenous elements like demographic, the share of rural population, but everything else is kept the same, that the income effect has to be explained within the model. The other method is to exogenously adjust the share parameters or the elasticities. We should distinguish 2 types of adjustments that people may make. One is just to account for demographics, and one is to account for the income effects, like, for example, the gasoline example that I mentioned. So the paper then goes into some detail about the difficulties of each method. So let me just quickly mention one aspect, which is the income elasticity. We can, if we change the share parameters, exogenously account for income effects that we say, okay, over time, the food share is going to fall. But that still leaves the issue of how do we represent the policy shock effect. Like if there's a policy shock that delivers an income change, then if unit income elasticity would not capture that. So these are the trade-offs that are discussed. So the adjusting these parameters is a common approach, and we list some of the model documentation that describes in better detail how they do it. So for those who are interested in seeing how these parameters are adjusted over time, you can refer to some of these descriptions. This last citation is a work that first do some econometrics using household data for the income effects, and then use the results to calibrate the LES function. Then the next major component of the paper is a comparison of different functional forms using a common CGE model. This is done by Brits and Roson using their GRDEM model. In their base model, they use an IDEX consumption function with CES subnets for energy and food. And then they substituted that consumption function with a CDE function or a LES demand function, or an IDEX without subnets. All of these are then calibrated so that we have the same GDP path. So in the paper, there's a long table of all 50 commodities. I just show a few here. So this is the change in the equilibrium quantities and prices for the year 2050 for some selected items. So for the LES function, the equilibrium quantity for food is generally higher, where the services are lower compared to the base model. The CDE model also generated higher equilibrium quantities of food, but lower for energy. And when we use the same IDEX, but without energy subnets, for example, for the energy subnets, so there is an impact too, even if we use the same IDEX function. The price differences are actually could be very big. In part, this is due to the calibration to a common GDP, but this is really driven by the different functional forms. So this, I think, illustrates the fact that even in the baseline, like not talking about policy shock effect, even in the baseline, there are significant differences due to the choices of our functional forms. Finally, I would not talk about this in detail, but I just want to note that the investment part of GDP for many developing countries is very large, 40%, even 50%. Unfortunately, the literature, both the theoretical and empirical literature about the commodity composition of investment and government is very sparse. We list in the paper a few papers that talks about it. So this is, I think, an area that really could do with a lot more coordinated work by the GTAP or bigger modeling community. Finally, I'm going to stop here and say that we identified some areas that we can fruitfully try to work together, as Rob emphasized. This work we can think of as different parts. We need to collect data from the different countries, and we need to estimate elasticities since they are quite country specific. And then we need like to collect the different projections from the various expert groups, and then to do more model comparisons of more functional forms. This is hard work, but there's obviously a huge public good aspect to it. And we hope somebody will help coordinate this task so we can share this this work going forward and to have future meetings where we can then share the results of both the empirical estimation as well as the model comparison exercises. Let me stop here. It is a long paper, but I hope you can find a part that you can zoom in for some useful information. We do not really have a recommendation of best practices other than to say that these are some examples of the effects of choosing different functions. And these are some of the papers that are trying other forms. The trade-offs of using more flexible functions are quite tough, but they do give this extra flexibility of having cross-price elasticities and the functions that deliver a more flexible degree of response to the income effects. So I look forward to the discussion. Thank you.
Thanks a lot, Man.
Let me try to turn off my share screen.
Yes, while you do that.
How do I do that?
I see a number of people in chat asking very relevant questions that we're not going to answer today. Is that my microphone that has a problem or somebody else not muted? Okay, now the sound is gone. So there's a number of questions that we're not going to answer today, which are excellent. For example, I saw a question coming by on structural change and how important that is for CGE models. Fully agree. It's probably the most important, in my personal view, it's the most important issue that we have, even more important than macroeconomic growth. But that's the topic of a presentation for next week, where we look at the supply side. So there's another question, for example, that I saw on trade. Again, I don't think that we will go into discussions on trade today. We will touch upon these issues next week. Now, I have a confession to make, that my internet connection collapsed for a short moment, and that means that that the earliest chats that were sent are no longer on my screen. I do remember one for you, Jean, that was about looking at GDP levels versus GDP growth rates for making projections. So maybe you can say something about that.
Yes. First of all, I'm sorry, that was my microphone that made the problem just a minute earlier. So I'm trying to mute every time I don't speak. So yes, this question is very interesting. Well, the answer is quite easy. What is important is GDP growth, mainly for reasons of consistency with the base year data that you are using. But the discussion we had on units is also relevant for this growth question, because what is important is that the growth rate is not in current prices. It has to be in purchasing power parities or volume, because it's the same in terms of growth rates. The level itself is not really, in my opinion, interesting in the CGE framework, except maybe to have a look at the implications of what you do in terms of modeling on the level of development, for instance. So that would be my answer for that.
Okay, thank you. Mum, can I ask you also to have a quick look at the earliest comments that were received? Or there's one coming in right now, but I might have missed some of the interesting earlier chat comments. If you want to touch upon one of those, feel free to pick one, read it out, and then give your answer. You would like to unmute yourself, I think.
Okay. I think there's only one last question that relates to consumption, which I will read to you. What are your thoughts on using econometrically estimated angle curves to independently project demand as a baseline? So this is something that we discussed in detail and give an example of those. So I think that is quite important that we use the estimated income effects to project the future. There are, however, limitations to this too, that the income effect that we usually estimate comes from the cross-section. That means the income effect is the comparison of the poor and rich within a country in a given year. And we need to then think about the next 50 years. So there's always this tension. Does the cross-section represent the future behavior of the people who are poor now but will become rich in the future? So that is one aspect that we need to discuss, that perhaps it would be also useful to compare different countries at a point in time. That might also be useful information instead of just comparing the poor and rich within a country.
Okay, thank you. I have another question here about to what extent can we use this information that we've gathered in this special issue, or it's my interpretation of this question. To what extent can we use this special issue and the information we have there for looking at single country dynamic CGE models? Because most of the comparison that was done in the papers and all the emphasis is on global models. But does either of you feel qualified to say something about how useful this information is for single country analysis?
I can, regarding the macroeconomics drivers, because it's really the same thing. The only difference, because while building a single country model, you still have to have a view of the global context. So the same data sources as the one that are discussed in the paper can be used, and the same techniques too. The only difference I see is if you're building a model for your government, for instance, then you might be constrained in terms of what is the trajectory for the specific country you are looking at. But otherwise, technically speaking, the issues dealt with within the special issue are completely relevant, in my opinion.
Something to add?
Yeah, I would just say that in a way, it makes it easier to think about one country. I forgot to mention that it is very important when we are constructing the global models to recognize that the accounting conventions of different countries are very different. So for example, health and education in many countries are counted as consumption, private consumption, but in some countries are counted as government expenditure. So the structure of our consumption functions are quite different for different countries. And so if you are just focused on one country, in a sense, it's easier to get it right. But as Florence said, is that the difficulties are the same. We need to think about the future, and we need to some way to account for these future income effects.
Yeah, if I can add to that myself, it's simpler, but at the same time, of course, the level of scrutiny of national forecasts and national projections tends to be higher than what we normally see in the global models. You often look at aggregated regions, and I do this in my modeling. I lump New Zealand with Australia, and then neither New Zealand nor Australia can claim that it doesn't align with the national projections because their national projections are different. Now, if I would do a model specifically for New Zealand, of course, I would have to do be much better aligned with the national circumstances in New Zealand, etc. So there is a level of scrutiny that is needed for a national model that's not there in the global models. And that was actually what I wanted to say about this is there's a lot of interesting stuff in the special issue that you can use for national modeling. There's a lot of information out there on elasticities, on type of functional forms that you can use, the way of thinking of how to make a dynamic baseline, the ideas that you need to consider on structural change, on macroeconomic development, etc. That's all there. But then you need to make a second step and think, what does that mean for my country? And you really need that step. You can't just take a global average and then say, well, that applies to my country. Just to give you one example, most of these global models use labor productivity to calibrate the GDP projections. Now imagine doing that for a country like Qatar, which has 90% or so of its national income coming from fossil fuels. Labor productivity does not explain growth in Qatar, right? It's the fossil fuels that you need to look at. So there are always national circumstances that you need to take into account. But the whole concept of what are the steps that you need to take? What are the different elements that you need to consider? If I have no national information, what can I fall back on? All that, I would say, this special issue on the global models, and of course the information in the global models themselves that are behind this, that's a valuable source of information for you. I have another question, and that is actually for Jean. So you're talking about adding fuels to the macro projections, adding some other natural resources and some other stuff that go beyond the pure macro. And I was wondering whether you can say something about, is that always an improvement, or does that kind of blur the line between the macro part and the CGE part? Can it lead to consistency issues, etc.? Can you say something about that?
Yes, of course. Maybe it's a matter of perspective that you have when you build your model. What we presented here in the macro paper is more of a toolbox for people who want to roughly take into account dynamics in fossil fuel natural resources or land supply, etc. And it, I would say it's, well, there is no clear conclusion of whether it is better or not in the paper, because actually it's not really discussed in what I've seen so far. The criterion that we had was a kind of plausibility, and if you have a trajectory for fossil fuel prices that are completely at odds with what can be expected, this might be a problem for all sectors using these goods. So this, I would consider it as an improvement if only a rough implementation of projections could be made, given that you check the consistency between the data you use and your own model. Regarding land, it's maybe, I think it's the same. It's if you consider any free trade agreement, let's say, for instance, you always have a part on agricultural sectors. And if the land price is completely not taken into account or not looked at, it could be problematic. So in terms of plausibility, it's not a scientific criterion, I recognize, but in terms of plausibility, having something that looks like what could be expected is better than having nothing.
Yeah, very good. Thanks for that. Two questions that are related now that I have for you, and that is about the very short run. The very short run in the recent past, how do you do with the fact that most of our database has an historical year that is already some years in the past? And how do you deal with that when you want to make projections from today, from this year on? How can you accommodate some of the recent trends in the adjustment of your base year, probably? Or how do you deal with that in your models? That's a difficult one. And it gets even more difficult with the next part. And that is, you have this updated, let's say, February 2020, but we all know that October 2020 looks a lot different than February 2020 with the COVID-19 pandemic. And how do we deal with the pandemic in our projections, especially in the short run? Maybe Man, I think you're particularly well suited for the first part of the question. How do we deal with these recent trends, and how do we deal with that And John, you might want to say something about the COVID effect on the GDP projections, the short-term GDP projections. But feel free to give a more elaborate answer if you have it.
This is always tricky. The first question about our base year is 2014, but now it's already 2019. There is, if you look at the latest accounts that will give you, say, the composition of GDP or the composition of consumption, that you can quickly update the share parameters. But then the question that now we have the COVID and the consumption basket of every country has now radically changed. So this is really a short-term phenomena that is probably not the concern of most of our long-range models. Right? If you're talking about climate change, right? Hopefully this COVID is a few-year phenomenon that we can ignore. But for those who have to deal with a short-run forecast, then I think this requires quite a bit of thinking. The economics profession is trying to deal with this very fact that A, how fast is the employment going to recover, and B, when can we start going back to the cinemas to change our consumption basket back to a more normal basket? I don't know.
John, anything to add?
Yeah. Regarding the impact on macroeconomics from the COVID crisis, I guess I joined somehow Mount Hope. I have no direct answer as whether one database is better than the other or what you have to do. Maybe what I can share to answer the question is my experience when I started working on CGE modeling. It was during the financial crisis, and we had these kind of problems. And while dealing with long-term projections, it was quite a difficult issue. And what I finally ended up doing is put in a sort of parenthesis the crisis and rely really on short-term projections for this period of time, like the IMF and so on, and just try to have a smooth transition to long-term dynamics, which, as Mon said, is not yet. It's not yet proved that the COVID crisis will really have a long-term impact on the growth path. So maybe it's not fully satisfactory as an answer, but that's the best I can offer, I think.
Yeah, thanks. Let me add something from what we do at the OECD with our modeling tools. First of all, we don't know yet the long-term impacts of COVID-19, so we're not really willing to come up with a baseline scenario and say this is going to be the long-term projections. We have several scenarios from the OECD on the short-term effects of the COVID-19. But again, it's multiple scenarios. The OECD normally doesn't do multiple scenarios for economic forecasts. But in this case, the uncertainties are so large that it's clear that you need something like multiple scenarios. So what a lot of models do, and I think this is at least the better models, I would say, the more advanced models do that, is they have for the short term, they are mimicking the forecasts that come out from IMF, OECD, etc. And they use that to calibrate actual GDP for the coming 5 years or so. But for the long run, nobody has forecasts, proper forecasts. So what all the models do is they transition then to what we would call potential GDP. So we transition to how high GDP could be in absence of shocks and short-term fluctuations, etc. So the more longer-term trend of GDP and the GDP potential. So that gives us already some effect, like you could use the latest COVID projections to say, well, there is a short-term disruption, but take the assumption, I'm not saying you should take that assumption, but this is an assumption that many people are taking, saying that potential GDP might not be affected by that. So that's one way out. But as I said, we don't feel comfortable at all yet to come up with any scenario for the long-term consequences of the COVID-19 pandemic. So this is just my personal view on what you could do, and there are many different ways to do it. On the updates of the base year from 2014 to 2019, I have to say, we used to have a very elaborate procedure where we're basically taking the social accounting matrix from the base year of GTAP, and then we have a number of targets for a number of variables that we want to mimic in 2019 or 2020, which could be GDP, it could be energy use, it could be kind of the broad construction of demand with food and with services, etc. So we'd have a number of targets, and then we would try to basically re-estimate a social accounting matrix for 2020 that incorporates some of these recent trends. Now, that's a very elaborate procedure. It gives you something that is relatively close to recent trends, but it's never going to be properly aligned with what's happening now because it only has a limited number of targets and a limited number of variables that you can use, because the reason why we have a GTAP 2014 is that it takes years to come up with fully consistent social accounting matrices for all the countries in the world. So always your base year data are a few years behind. I know that there's a lot of models out there that actually take a much simpler approach and that basically say any year after my base year is a modeling simulation year. And I just run the model and I just don't present what's happening in 2015 to 2020. And I just hope that 2020 is not too far off from reality. So that's what happens. I have a last question, but we have to wrap up very soon. But the very last question then, if you want to shock COVID-19 impacts on GTAP dynamic, which variable in the model will I shock? Jean, a very short answer if you don't mind.
I'm not familiar to the GTAP model itself because I worked on another model. So I'm sorry, I think I can't.
I think that IMF, for example, has projections out there for COVID-19. The OECD has short-term forecasts. There is a special issue, if I'm not mistaken, in environmental resource economics recently that talks about the economist's view on COVID-19. So you can also look at that. I don't think you'll ever find a data set that says, oh, here are the short-term impacts of COVID-19. You can just plug it into your model. A lot of it is guesswork. A lot of it is different experts having different opinions and therefore having different shocks that they want to put in their models. So you just have to review the literature that's out there. Well, with that, I thank you all for your contributions, the excellent questions. Man and Jean, very much thank you for your presentations and also your contributions to the discussion. I want to highlight, somebody already beat me to it by providing a link to the Journal of Global Economic Analysis special issue where all these presentations and the papers underlying these have been published. So they're all out there. Also the ones that are presented next week. So you can click on that link or you can just search for the latest issue of the Journal of Global Economic Analysis to do that. So all that rests for me is to just thank you all for your attention and invite you back for a seminar at the same time next week with the next 4 sets of speakers. Goodbye.
Thank you.
Goodbye, thank you.